right, so section 2-3 is now deductive reasoning. We talked about inductive reasoning. We talked about conditional if-then statements with the converse, the inverse, and the contrapositive, and now we're getting to the deductive reasoning. Deductive reasoning you gain from facts. You take facts in a case and make a conclusion about it. And so oftentimes that's what detectives will do. Detectives are not going to arrest you for murder until they have some pretty strong evidence against you, correct? You might be dripping with blood and holding the murder weapon. And they may not arrest you at that point. Well, they probably will detain you. Pretty sure they would. But they're not going to convict you right then and there of murder. They have to go through a trial, right? And in the trial, they would bring up all kinds of evidence, wouldn't they? Then based upon that evidence, using their, because they don't know for sure what happened unless you confess, isn't that correct? And even people who confess, aren't there some people that confess to a crime and they really didn't do it? Doesn't it boggle your mind as to why they would do that? Maybe they want the attention, maybe they're lonely, maybe they have no place to live, and they just figure jail is better than nothing, right? But nobody really knows what happened unless you're actually there. Unless you're actually there. So they do go by forensic science. Forensic science is all about facts. And they use those facts to kind of recreate what happened. So that's your deductive reasoning. For geometry, we're going to use two types of deductive reasoning. The first one is your law of detachment. And this is the geometry notation. I'm going to tell you exactly what it is in just a second, but write that down. If P then Q is a true conditional, remember P is your hypothesis, Q is your conclusion. And we know for sure that P is true. If you're told it's a true conditional, and definitely P is true, then Q will have to be true also. So I'm going to give you a little example of what that looks like. You might see something like this. If it is cold outside, okay, so if it is cold outside, then I will wear a coat. That's your true conditional. If it is cold outside, then I will wear a coat. You know that you have the law of detachment if you see a full true conditional. So if you assume that it is definitely cold outside, you walk outside, you determine, yep, it's cold. Well, then you know that I'm going to wear a coat. If this is true, this will always follow. Whether or not that's true for you, this is true for me because I said so. Okay? Trust me, if it's cold outside, I'm wearing a coat. Then what they're going to say is, Mrs. Murray, they could say a couple of things. Mrs., let's see. Where's my eraser? Ah, found it. You're going to see a partial conditional, just a partial conditional. You're going to see the hypothesis. So you're going to see it is cold outside. What can you conclude? Who? Who's you? Mrs. Murray, here's your conclusion. Mrs. Murray will wear a coat. This is what you will end up concluding by the law of detachment. This is what you have to come up with. This is all given to you. If it is cold outside, then I will wear a coat. Or it'll probably say, then Mrs. Murray will wear a coat. And then the partial conditional will say, it is cold outside. So your conclusion has to be, oh, Mrs. Murray's going to wear a coat. Okay? What if I said, if you have a dog, then it is a mammal. There's another one. If you have a dog, then it is a mammal. Is that true? Are dogs mammals? Yeah, hopefully you've learned that, right? Then the partial conditional will say Sparky is a dog. What can you conclude? Sparky is a mammal. Do you see how this is a partial conditional? You wouldn't say if you have something called Sparky, then it's a dog, because is that even true? Ricky, head up, please. Could you turn this into a conditional? If you have a Sparky, then it's a dog. Does that make any sense to you? This is just a partial conditional. If Sparky is a dog, there's your if-then part. Then what can you conclude? Then Sparky is a mammal. So, law of detachment has a full conditional, and I would write that down there. Full conditional and a partial. Because you're going to see the difference between detachment and syllogism right now. Did you not write it down? You're slow. Alright, so here's law of syllogism. The law of syllogism is very, very much like the transitive property. So you might want to put over here similar to transitive property. Remember that's if A equals B and B equals C, then A equals C, right? You're going to end up with a law of syllogism. You're going to be given two full conditionals, and then you have to come up with your own conditional. So they're telling you here, if P then Q and Q then R, those are two full conditionals. These are notations for conditionals. Our true conditionals, so this time you're given two, whereas here you were given just one. Then P then R is also true. Do you see how the conclusion and the hypothesis in both of these conditionals are exactly the same? So all you have to do when you're given two full conditionals is take the hypothesis from the first and attach it to the conclusion of the second. You don't have to come up with a whole new conclusion. You have to look at what they have in common, take that out of it, and put them together. Question?
What's the R?
Pardon? The R is just a different. The R is a different conclusion than the Q. I'm going to give you an example here to show you in just a minute, but I want you to get it written down. Have you ever heard the book, If You Give a Mouse a Cookie? Okay? Remember how that goes? If you give a mouse a cookie, then he'll want a glass of milk, right? If you give him a glass of milk, then he'll give a milk mustache. I don't know, that's not really part of the story, but you get the idea. So it keeps going on, and they keep using what they did previously, and they come up with another conclusion. If he has a milk mustache, then he's going to want to clean it off. If he wants to clean it off, he's going to need to get up on the sink. If he wants to get up on the sink, he's going to need some help. And remember that story, those of you? Hopefully you had it read to you. I actually have the story, but if we have time, perhaps I'll read it to you, but I don't think we'll have time today. But anyway, that's using the law of syllogism in that story. So if I said to you this, if it is sunny outside, then Sandy will wear shorts. Okay? Isn't that a full conditional? If it is sunny outside, then Sandy will wear shorts. Look at how your next conditional looks. Your next conditional has got to start with if Sandy wears shorts, because isn't that your conclusion of the first one? Whatever the conclusion of the first one, the next one, for it to be the law of syllogism, has to start as a hypothesis the same as this. So if Sandy wears shorts, then she will wear flip-flops. So what can you conclude? What can you conclude? Notice that these are the same. Sandy will wear shorts. Sandy will wear shorts. Take that out and put the other two, sandwich them together. What are you going to conclude? If it is sunny outside, then Sandy, you had to change that to Sandy, then Sandy will wear flip-flops. Doesn't matter. You take the repeated part out. Whatever's being repeated here, take it out. Are you listening? Boys, if I have to talk to you one more time, one of you sitting over there, one of you sitting over there. So stop. All right, so whatever is being repeated gets pulled out of it, and the hypothesis of the first one and the conclusion of the second one get put together as your final conditional. So here's your final conditional. If it is sunny outside, then Sandy will wear flip-flops. And as you can see here, notice that the P comes from the hypothesis of the first conditional, and the R comes from the conclusion of the second conditional. The difference between syllogism and detachment is you have two full conditionals here, only one partial here. So let me give you a few examples and see how you do. Okay. First question. First of all, you're going to be given two statements. You have to determine, are they two conditionals or a conditional and a partial? Is that two full conditionals? Well, first of all, if it is snowing, then it is cold outside. You have to accept that as true. So it's not snowing. Can you make a conclusion from that? Well, your conclusion would be to say that it's not cold outside, but is it possible for it to be cold outside and it not snow? Yeah, so that's not a true, there's not a true conclusion that you can draw from this. So this is neither the law of detachment nor the law of syllogism. It's neither. Because you cannot draw a valid conclusion for that. So this is true, and this was true. But between those two, we couldn't make a connection and make a valid conclusion. Remember, you're detectives. However, nobody should be packing up. Look at this one. What do you notice about this? If you drink milk, your body gets calcium. Is that a full conditional? If, then, right? Is this a full conditional? If your body gets calcium, you will have strong bones. Do you notice that what you ended up with here, you started with here? Which one gives you two full conditionals? The law of syllogism. So this is the law of syllogism. What do you conclude? Get rid of the double part. If you drink milk, you will have strong bones and teeth. Get rid of any part that's double, right? And then last one. If you study, you should pass the test. That's a full conditional. Frank did study. Is that a full conditional? No, it's partial. Stop packing up. I will hold you. We don't pack up. We go till the bell ends, and I dismiss you. So this is a partial. What can you conclude about Frank studying? Frank should pass the test. Stop. That is the law of detachment. Frank should pass the test is what you concluded. I hope you wrote those down and didn't pack up beforehand, otherwise you're gonna have a sad, sorry time doing your homework.